Hello everyone, welcome to the session. Hydraulic missions. First we'll see what is this hydraulic mission. Hydraulic mission which converts hydraulic energy to mechanical energy or else mechanical energy to hydraulic energy. So the machines which will convert the hydraulic energy to mechanical energy or mechanical energy to hydraulic energy, depending on this two sentences, the hydraulic machines is classified. First we'll see how the fluid machines is classified, and later we'll see how those two statements are classified. The first one, classification of hydraulic machines. First one is hydrodynamic machines and the second one is positive displacement machines. Here in this course we are going to discuss about rotodynamic machines, but not these positive displacement machines. Okay, this course is related to rotodynamic machines, but actually the classification of fluid machines is rotodynamic machines and the positive displacement machines. The first one, we'll see the classification of these rotodynamic machines. The first one is turbines and the second one is pumps, compressors, fans, blowers. And just now we've seen how the hydraulic machines stated. We've seen two statements, right? The first one is it will hydraulic energy to mechanical energy, and the second one is mechanical energy to hydraulic energy. The first one, the machine which will converts, or the device which will converts hydraulic energy to mechanical energy is turbines. And the next one, the devices which will converts the mechanical energy to hydraulic energy is compressors or pumps. So in this course we are going to discuss about turbines and the pumps. Okay, and again these turbines are classified as hydraulic turbines, gas turbines and the steam turbines. But in this hydraulic machines course we'll discuss about hydraulic turbines, and these gas turbines and the steam turbines will we have another course which is like thermal engineering. Clear? And coming to this classification which is like pumps, and these are classified as compressors, pumps, fans and blowers. And now see here, turbines are energy extracting machines or devices. Pumps are pressurizing devices. And now depending on how the pressure is rises, these classification has been done. Like if the device is rising less pressure or low pressure, these comes under fans and blowers. That means the fans and blowers will rise the pressure very less when compared to the pumps and compressors. And these are the medium pressurized devices, and compressors are the high pressurized devices. And this total course we are going to discuss about your hydraulic turbines and the pumps. Okay, and the next we'll see how these hydraulic turbines are classified. The first one, according to the type of energy inlet. That means these may be impulse turbines or these may be a reaction turbines. See, in impulse turbine, what is the main difference between impulse and the reaction turbines? In these two turbines, the energy inlets, okay, the energy inlet for the impulse turbine is kinetic energy. And coming to the reaction turbine, here the energy inlet is potential energy and kinetic energy. Okay, so in the impulse turbine we have only the kinetic energy as the energy inlet, and coming to the reaction turbine we have the potential energy and the kinetic energy as the inlet. And the next one is according to the direction of flow. According to the direction of flow, it will be having four classified forms, which is like tangential flow turbine, radial flow turbine, axial flow turbine and the mixed flow turbine. First we'll see what is a tangential flow turbine. If the direction of flow is tangential to the runner or to the turbine, those turbines are called tangential flow turbines. If the direction of flow is tangential to the turbines, it is called tangential flow turbines. And the next one, if the direction of flow is radial to the runners or the turbine, then it is called radial flow turbines. And the next, axial flow, if the direction of flow is parallel to the axis of the blades, rotor, runner or turbine, anything. Okay, if the direction of flow is parallel to the axis of the turbine, then it is called axial flow turbines. And here, coming to the fourth one, this is mixed flow. That means inlet is radial flow, outlet is axial flow. Okay, that means the inlet of the flow will be, the direction of flow for the inlet will be radial, that means this one, and the outlet of the flow is axial, that is this one. So that's why it is mixed flow turbines. And now impulse turbine is a tangential flow turbine, and the radial flow turbine is used in old type turbines. So today nowadays these are not using. And next, coming to the axial flow turbines, the Kaplan and the propeller are used as axial flow turbines. And the mixed flow turbines, the best example for this mixed flow turbine is modern Francis. Modern Francis turbine is a mixed flow turbine. And next classification for hydraulic turbines, it is head at inlet of the turbine. Head at inlet of the turbine. If it is having high head, we call it as high head turbines. If it is medium head turbines, and the next one is low head turbines. That means the turbines which will having the low head, medium head, high head, these are classified accordingly. And next, high head turbines are Pelton wheel turbines or impulse turbines. Medium and low head turbines are reaction turbines, and the medium head is modern Francis, and the low head is Kaplan turbines or propeller turbine. Next, according to the specific speeds, okay, impulse turbine or low specific speeds, and reaction turbines or medium specific speeds, and these are also comes under reaction turbines. But the best example for this high specific speed is Kaplan turbine, and medium specific speed is modern Francis turbine is medium specific speed turbines. And now for impulse turbine, these will gives you a low specific speed. Because of that, you are going to get low efficiency for the impulse turbine, high efficiency for the reaction turbines. So finally, efficiency of impulse turbine is very low when compared to the reaction turbines. And now next we'll see what is the main difference between impulse turbines and the reaction turbines. And this is the comparison between your impulse and the reaction turbines. The first one is the best example for your impulse turbines is Pelton wheel, and all these turbines which is like turbo impulse wheel, Kirchhoff turbine, Banki turbine and Joule turbine, all these comes under impulse turbines. And the reaction turbines, the best examples are Francis, which is like modern Francis, and propeller and the Kaplan turbine. These are very important reaction turbines that you are going to discuss in this course. And next, coming to the second point, tangential flow. Okay, already we're seeing this. The flow which is tangential to the runners is tangential flow turbines. The example for this tangential flow is impulse, and that too Pelton wheel turbines. And coming to the axial flow turbines, in reaction turbines, axial flow turbines are Kaplans, and the mixed flow turbines are Francis. And in impulse turbine, we have high heads but low discharges. But coming to the reaction turbines, we have low heads but high discharges. And the last one is, here we have low specific speeds in the impulse turbine and the high specific speeds in the reaction turbines. So because of these high discharge and high specific speeds, the efficiency of the reaction turbine is high. but the efficiency of impulse turbine is low when compared to the reaction turbines. Okay, thank you.